Okay, I'm back for more LeetCode. So we're gonna do 3 easies, 3 mediums, and attempt to do at least 1 hard. So let's get started. Let's find our first easy code. Okay, search insert position. Okay, search insert position. Given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write it in log n time complexity. Okay. So I think this problem in particular doesn't, for me at least, I know that we're probably going to end up using a binary search. So binary search, we would do const middle equals target, or sorry, nums sub dot length divided by 2, and we'll do math dot floor. I guess we have to do like start equals 0, end equals nums dot length. And I will do while start is not equal to end. We're just going to put an and false here because I don't want to accidentally run it, and then we have an infinite loop. If they're equal, then we've probably figured out the index that we need to insert at, so we're going to just return start. We could also return end, but you know, they're going to be the same. This is going to be end minus start, and we could say nums sub that, and we can say if middle equals target, we'll return middle. Actually, we need to do this. Else if middle is less than target, else. So in this case, middle is greater than target. It's the only option really. So I feel as though if the middle value is less than the target, that means we need to look in we're too low, so we need to look in the right hand quadrant. So we need to say start equals middle index. Otherwise we say end equals middle index. And I think this is very close to a solution. Except for this and false. We could just run it to see if it passes the base cases. Okay, the target is 2, we hit the time limit. And the value will not be found. Okay, well. We'll set like a, we'll just keep track of how many times we run. We'll just say 5. And then we'll do count plus plus. And then we'll do some console logs of start, end, middle, index, middle. I'm curious if it shows an object here or something more detailed. Right, so I was saying 5 is in the middle, which is 4 minus 0, 2, 0, 1, 2. Fine, yeah, I guess. And then 5 is greater than, so that means we're in the wrong quadrant. So we're gonna look from 0 to 2. 0, 1, 2, and then the middle is going to be 3. That's correct. 3 is greater than the target. So we're gonna do start is 0, end is 1. The middle index. Okay, so we get stuck in this infinite loop of not changing the start and the end. So at this point, we know that when we hit this, 1 is less than 2. So middle is less than target. So we are going into here. So I feel like start should be +1 then, just to handle this edge case. And look at middle. If we look at start is 0, start would become 1. Actually, it would be middle index +1, which would make it 2. Actually, let's think about this, because we gotta make sure that the value we're getting actually makes sense. Oh yeah, the middle index is 0 at the moment. We take middle index +1, set it to start, and then it'll be 1, and 1 is the correct insert index. So we could run it again, see if we get a different result. And then this is the third test case, where we're basically going out of bounds on the right hand side. We're outputting 2. Hey Anvi, how's it going? I'm using JavaScript. Very basic vanilla JavaScript to solve the problem. Yeah, I'm looking forward to getting together with family for Thanksgiving, for Christmas. How about you? Do you celebrate Diwali? There's a chance we'll be going to the Poconos for for Diwali. Gosh, for Thanksgiving. There's a chance. Output. Okay, let's think about this. So the arrays 0 to 4, but I'm okay. So somehow the middle index is 0 here. Start plus end. What am I doing? Oh, what am I? Yeah, why am I doing minus? Minus is not how you do an average. So I don't know why I was doing that. Oh, I see. I've not heard of Bandage or Diwa. Diwas? Diwa? There's a chance that we're going to the Poconos, which is like the local mountains. It's the mountains that people in this part of the US go to for decent skiing or snowboarding or general winter weather hiking. Oh, we can clean up this code now. We good. Gotta get rid of count. Are you submitting too frequently? Okay, so, and then we can think about the complexity here. In terms of time complexity, it will be log of n, and the reason we know this is because log n happens when you're like doing a divide and conquer algorithm, which we're doing here. Every time we look at the middle, we split the problem in half. And if we find the index, that's the one we return. And if we are, depending on what section of the problem we need to look at, we will switch from left to right. And if we get to the end without finding something, then we'll just say that that's where the thing needs to go. So, and then the memory complexity is big O1. We don't take up more memory based on the target or the nums. The input doesn't affect our memory requirements, just our runtime requirements. So we're gonna submit this, see where we end up. Okay, so we ran in 0 milliseconds. We hit this category of 100%, which is good. Take a look at another solution. So interestingly, they start with this concept of high, and it starts at -1, while low is less than or equal to high. So low can exceed high before we break out of this loop. They do get the mid, which we did. I'm surprised. I mean, I guess it's not faster because they don't cache this. This is also interesting. So they not only do they start at -1 of the length, they also -1 for high and +1 for low, which we didn't. We didn't have to do the -1. We only had to do the +1. and then they just return low. So a very similar solution. Just a little bit different calculations there. Let's look at a slower solution, what that might look like. Okay, so that makes sense. Literally just linearly going through the array to find the target value. They didn't really attempt to do a divide and conquer solution. So this would run in big O(n). Worst case scenario. Actually, if the target is less than or equal to IC, do I see? I'm trying to understand why this even works. Basically, if you go through the whole array and you didn't find the element, it seems like that means it's larger than every element in the array, so return the length of the array. But if the target is less than or equal to nums, yeah, I guess that does make sense. So like as you go through the array of numbers, if you eventually find a numbers, then you will be less than or equal to it. But I would have thought that this needs to be greater than or equal to. Because we want to keep going. Oh, because the number will be larger. Yes, if we're thinking about what the target is going to be larger potentially. We keep going until, oh, it's not larger or it's the same. AKA it's less than. If it's no longer larger than the element or the same as the element, then that's the index we're targeting. So, okay. I guess it's a little bit challenging. I know it's like very simple comparison, but I don't know. I wonder if it would make more sense to write this differently. I don't know. So that was that slow. This one's even slower, and my goodness. This is actually like insanely slow. This is n squared. So wow, and x equals target, x is greater x plus plus. Whoa. Interesting. It's very hard to reason. I'm surprised that this code works. Just looking at it, x equals target. So we're saying we're creating a new variable storing the target number. We're going to keep iterating until x is greater than or equal to the first number, and then we'll decrement x. We're looping over. Oh, it's got to be a while it's greater than or equal to, yeah, or for greater than or equal to. Okay, so we'll keep decrementing x, which doesn't make any real sense to me. Keep decrementing x, and then if nums index of x, which is like, this outer loop is just so pointless because you have this extra condition that x equals target, and x is only target on the first iteration, so you're just wasting time. This is actually just doing extra work for no reason. If x equals target, wow, and then they do another index of, like, they literally have the index of already done. They do it again when they could have like cached it. So if I feel like this would also, I'm surprised this doesn't return false positives, because if like nums was, for example, 1, 2, 3, and how can we make this work? If nums was like 1 and 5 and target was 3. Oh, okay, I see how that works. Okay, it's coming to me now why they did it the way they did it. Because so I guess they aren't doing extra work, now that I understand it a little bit better. They're trying to find where we can insert this at. Right, so they're basically working from the target value and working their way backwards until they find out, oh, I can put it there. And so if basically it's actually kind of clever, but it's really complicated, and this is the thing about like clever code. It's not always the fastest, not always the best code, but it's an interesting way to solve the problem for sure. But they basically are working their way backwards from the target value to like the lowest value of nums, and trying to find the basically the biggest number in nums that's between target and that value, I guess. So basically, in my example, if it was like nums was 1 and 5 and target was 3, they would try 3 and find the index of 3. They wouldn't find it. They would try the index of 2. They wouldn't find it. They would try the index of 1 and be like, oh, index of 1 is here. I've determined that with this, but is X target? 1 is not target. Target is 3, X is 1. So we go down this one and we say that we insert at the index 2. Or the index 1, I guess, since 1 is at a different index. So very, very complicated, basically like n squared. This has a really bad worst case scenario because it's as bad as the distance between the numbers, and that distance, the distance between the smallest number in nums and the biggest at the target, which if this is a really big number, actually it's the distance between target and the biggest number in nums, if it's even in target. So I guess, yeah, it's potentially really bad runtime if target is really, really large. If it was like 1,000,000, then this is gonna run, and nums was 1, this is gonna run 1,000,000 times. And then even if it was like 1,000,000 and then there were 5,000 elements, 1 to 5,000, this is gonna run 1,000,000 times, this is gonna run 5,000 times, this is gonna run 5,000 times, this is okay. Taking a look at this one, I'm actually curious how this could possibly be slower, how anything could possibly be slower than this one. We got this. We even like declare these variables early. I'm wondering like how much does a log actually affect your runtime? Is it considerable? And we can see that they have a similar solution to the best, one of the better solutions. They have the -1, +1, -1. So I'm surprising that this is potentially slower. Okay. And again, this looks like it would be log n. I think the only problem is they have so many conditions. So they first see if the mid is there, then they see if mid's greater than target, and if, ooh. Basically, they're seeing if the thing, if target is between the left and the right value, then they return mid. Then they see if we're basically at the end, then we return mid plus 1. But they see if they're basically at the beginning, and then they return mid. And then they see if it's greater than, well, okay, all right, interesting. It's okay, it's not, it's also not binary search. They don't cut the problem in half every time. They just increment or decrement left and right. So that's another thing that's going to make it go slower. Okay. That's just looking at other algorithms. I think I'm going to move on to another problem, but let me just make a note of what I've worked on today. This is search insert position. And we're at 27. I spent a lot of time just reviewing other people's code, but that's okay. Let's find another easy. Length of the last word. Given a string S consisting of words and spaces, return the length of the last word in the string. A word is a maximal substring consisting of non-space characters. The last word is world with length 5. Okay. Okay. So we need to, basically, ignoring spaces, find the last word. So I'm gonna create a variable called end, and I'm gonna set it to s.length. Basically, the idea is I'm going to work my way from the back of the string and work my way back character by character. First, I'm going to find the first word and mark its ending. Then I'm going to find the beginning of that word and mark its beginning. So let end equals s.length. We are just assuming that the length, that the end of the word is at the end of the string, but we're going to write a loop that says otherwise. We're basically going to be n minus, we're going to do s sub n minus 1 equals empty. We'll do n minus minus. Basically, while we're looking at an empty string, we need to keep going. And then next, we're gonna have to find let start equals end. And basically, while s sub start is not equal to empty, well, not empty string, the space character, we're gonna do start minus minus. And I think we have to do let's just start minus 1. And I think we do end minus 1 because we know that we hit a character. Do we? I guess it's possible we hit the beginning of the string just to handle an edge case of, for a reason, this is, let's look at the constraints. S contains only English letters and spaces, there will be at least one word. Okay, there'll be at least one word, so we can do this to add a sub optimization. But basically we could do return end minus start. So we could run this, see how we did. We do get passing code. Now, something that I can imagine other people did was probably doing a s.trim split on space characters dot at -1 dot length. This is like if you wanted to do it in one line of code, I think that this would do the job. But one line, you gotta think about the in terms of optimization. I mean, we could do trim end as one optimization for that chunk of code. So s.trim end, I mean, that's trim end is it's fairly expensive because you need to create a new string, and creating a new string is automatically going to be big O-N. Split regex, that's, I mean, it's going to be big O-N, you're going to create multiple strings again. And then we get the last string of that split and then get its length. It's just like a lot of overhead. Now granted, because these are probably running in C level code, they might be super fast, even faster than this code, which is something to consider. But I don't know, I just don't think that it's likely to be that much better. Let me just run it one more time with our code, and we'll just submit it and see how we do. Wow. So for this one, I think we have to do start is greater than 0. Otherwise it just keeps going. Okay. We could probably also do this, and we'll still be for better. You can't really do better than 0 milliseconds though. But I am curious what the runtime of this is. Wow, okay, it is super fast. I will say that this might not be what a interviewer is looking for. That this is more likely what the interviewer is looking for. So I would go with this solution. Let's look at an alternative best solution. So they did do similar to what I was saying. Instead of doing at -1, they did a pop. They did a split. Interesting. So they trimmed both sides, which we discussed as slower. They replaced every set of spaces with just a single space, which is kind of unnecessary. You don't really need to do this. So it's an extra step, because ultimately the only thing that matters is the last word. It doesn't matter how many other items you get. This is just adding extra work. Split here, I use the regex, and maybe this is like, it could be, I imagine that this is faster than a regex. But I mean, they could have, if they're already doing a regex, you could just do the regex here. I didn't have to do a regex per se. And then they pop, which is basically getting the last thing, and then get the length of that last thing. So they did a solution that I thought somebody might do. Let's look at another solution. Slightly slower solution. Last length 0, last char is space, false. So char of S. It would be good to have a declaration of let or const here. If char is, so for some reason, okay, so last char is space means is the previous character that I looked at a space, yes or no? And if it is, if it was a last, if the last character was a space, then and I'm looking at something that's not a space, then I'm going to reset the length and say that it's not a space anymore, and the length will increment at this point. So basically, the issue that they had for this algorithm was they did it forward to, they went all the way through the string, which, you know, both algorithms, mine and theirs, they're both big O, but that's the worst case scenario. The average case or best case scenario for my algorithm is it only goes from the back till the first word. Their algorithm always goes through every single character. You see, that's just for of S. There's nothing breaking out of this loop. So they always go through every single character. So that's why this is going to take a little bit longer. We'll go to this one. See if we can figure out. Oof, that's a doozy. We do see this idea of working our way backwards. And then while I is greater than or equal to 0, while S sub I equals, we're going to increment the, it's not equal to, okay. Okay, so basically they're going like character by character-ish, and initially they're going to, like, if there's just spaces at the end, this for loop's just gonna run until finally we find something that's not a space, and then we're gonna hit this while loop, and then we're gonna increment count, we're gonna decrement I, and then we're gonna look for a space again. Or if I is going out of bounds, then we return count. So basically, it's fairly similar to our algorithm. I'm surprised that it's that much slower than the previous one we were looking at. This ran in 2 milliseconds, this ran in 1 millisecond. Because they're still working from the end. They're not doing that many comparisons. Like, how expensive is a console log? Like, is that gonna increment by a millisecond? Anyway, they're doing it, they're doing what we did with a little bit more variables. I mean, What does this flag variable do? So they just declared this variable for no reason. They logged for no reason. They created length for no reason. I mean, I don't, yeah, because this only happens once. So just putting this here instead of this, I think is totally justifiable. Okay, let's look at the 3 millisecond. Okay, and this one's just going in order. If we see a space, the total becomes 0. This is interesting. Oh, because we trim first. I was gonna say, because if there's spaces at the end, then this is not gonna work. But since they trimmed, they could have trimmed end. But other than that, the issue is they went in order. Maybe this trim adds a little bit more time because it's doing the left and the right trimming, creating a whole new string. And then we have another trim. Got the length, current word. Ooh, okay. Yeah, that'll be expensive. String concatenation is very expensive. Current word plus dot length is very expensive. So rather than just keeping track of the number, which is all we care about is the count, they kept track of the actual word, which yeah. This would be like essentially n squared, just doing this, because every time you're concatenating the string, you're creating a string with 1, then you're creating a new string with 2, which requires you to go through every character, creating a string with 3, which requires you to go through every character. If you keep doing that, you get the sum of numbers from 0 to n for 1 to n, which is an n squared, big O n squared algorithm. Okay. Alright, we gone through all those. Let's look for another easy. And let me just go back for a moment. Length of last word. Okay. And we'll go back forward. Do another easy. Do +1. You're given a large integer represented as an integer array digits. Okay, so we have an array of numbers where each digit is the ith digit of the integer. The digits are ordered from most significant to least significant, left to right order. Large integer does not contain leading zeros. Increment the large integer by 1 and return the resulting array of digits. Okay. So for this particular one, we could cheat a little bit. We could cheat in that we could just like convert the array of numbers to a number, add 1 to it, and convert it back to array numbers, but that seems incredibly slow. So what I'm going to do instead is I'm going to create another function. Actually, I'll just do it here. basically going to create this variable to tell us where we're going to add 1 to. And then we're going to add 1 to it. So we'll say digits at equals, we can just do plus plus, I guess. Probably. Put plus plus before, because we want the plus plus to happen, and then we store the result of plus plus in here. If result what are we doing? If result is 10, then digit sub at equals 0, and then we have to do plus 1 to digits at minus 1. Basically, we need to carry the 1 over. Finally, what do we return here, even? Are we allowed to do it in place? We return digits. The other thing that we need to consider is what if we have 999? We need to add a new digit. So what I would want to do is if at is less than 0, then we're gonna have to say digits dot shift a 1. Else we'll do all this stuff. So basically this is how eventually this has the potential to be called enough times to where we hit the very beginning of the number all the way to the left, and this at would be 0, minus 1 would be -1, and we don't want to use -1 for digits, so we need to add the 1 to this to the left side of the array. So if at is less than 0, that's what we do. Otherwise, we just keep we just do the +1 normally. Let's just run it, see if it passes for some of the simple cases. Oh, it's unshift. I gotta remember that, so shift versus unshift, when you're trying to think, both of them do something to the array. They both do, I believe they both do something to the beginning of the array. And if you're trying to remember which one is which one adds, which one removes, is unshift add, is unshift remove, the way, and I didn't remember it in this instance, but the way we remember it is the number of letters in unshift is greater than the number of letters in shift. And so since, if you can just remember that would help you to remember that this is the one that adds, this is the one that removes. Okay, and then we did hit the 100% mark. Now, 0 milliseconds is pretty good. We're not going to do better than 0 milliseconds. Typically speaking, JavaScript doesn't like to call functions. So it's going to be better for JavaScript if we wrote a for loop that would work through each number and increment it by 1. I mean, we hit the 0 milliseconds, so we don't have to do that, but we could probably see somebody who did do that. But we use recursion to solve the problem. So if we click on this, maybe we'll see. Okay, this was something I considered doing. Taking the digits, turning it into a string, turning that into a big int, adding it with another big int, turning it back into a string, splitting that string, and parsing each item of the string as a number. This is, I would define this as cheating. This is not what an interviewer is looking for. Although in real life, you probably would do it this way because it's easy, but it's not really showing your expertise with algorithms. You're just using existing APIs to do the work for you. The interviewer wants to see that you know potentially how to convert this number to an actual number, not using built-in functions. Like they want to see you like multiply and add and push numbers and things along those lines, not use these built-in functions like this. So I would call this cheating. Look at this solution. They are also cheating, which is kind of sad because they don't have a fast solution either. I'm curious what they did so wrong, and I always think about, is console log so expensive that it's going to make the difference between this and that? Or is parseInt faster than number? Maybe? Maybe a number is heavier. They do the same join, they do the same split. So surprised that it's 1 millisecond difference. Okay. So digit sub I. Oof. +1 is less than 10. Digit sub I +1. Return digits. Okay, so they seem to have done it in place and without recursion. I think that they could have been a little bit more clever with this. They probably could have incorporated this into here, this idea. Basically, the issue is actually, I think they literally could have. I don't even know if they needed this per se. They could have just did digit sub I ++ no matter what. And then this would have handled it from there on. Yeah, it seems like a lot of extra work. It's really hard to reason. Apparently it works, but basically they're like processing each 10 and like resetting things to 0. Stephen J is less than less than L. J++. I think a lot of this is overkill. A lot of it's overkill. It's really hard to reason. You don't want to overcomplicate it. It's like it's To me, it's actually better to do this than to do something really complicated, convoluted. All right, how about this? Okay, well they not only did they cheat, but they also did so much extra. Sum is sum plus digits of I. Why did they do the sum? They just randomly did sum when they didn't need to. So that's probably affecting their runtime. But otherwise, they did big int. I don't know, were they just like trying to submit and steal someone else's answer? And then this one, yeah, I guess it makes sense. Wow. So they assumed that two-stringing a number would add commas to it, which I don't think usually happens. So I don't think you need to do this clean idea. And they even logged it, so they should know that you shouldn't have to do this. But for whatever, oh my god. For whatever reason, they were like, okay, I'm gonna take, oh my, okay, never mind. Okay, I'm making a misunderstanding here. So an array, this is an array, that's very important. When you do string it, yeah, it's gonna be number, comma, number, comma, number, comma. So yes, they are removing those commas. They could have just, everyone else did this, they could have just joined on the empty string and then big inted it. Plus 1n. 1n is just like a shorthand for a big int. Putting an n at the end of your number is shorthand for a big int. Array from string number. Okay. So that would, yeah, convert this string into an array of characters and then run the number function for each item. I actually didn't know that there was a second argument for array.from, so I'm actually learning something new from one of the slower runtimes here. So that's good. Always good to learn. Okay. Let's go to problems. And let's find a medium. Okay, so I did start this the other day. So just give me a moment. I'll go back. This one. Okay. And then we'll go back forward. String to integer. Okay, implement my a2i function converts 32-bit signed integer. The a2i as follows. Like I said, trimming is cheating. So we want to, I guess we'll make like a finite state machine. I think these are pretty helpful. So we'll say let state equals something. I'll create a type called state, and we'll say beginning, or yeah, beginning. And we'll say index equals 0. And we'll do while index is less than s. And then we'll say if state equals beginning. Oh, we're not doing TypeScript, are we? Basically, if we're in the beginning, then if state or if equals s sub index. So if character equals the space character, then we'll just do index plus plus. Else we'll say state equals, I'll go to create constants at least. Const state sign, what is called spaces then? Sign or number equals sign or number. Sign or number. I will say else if state equals sign or number. So we'll say const state, sorry, sign equals 1. And then so if character equals negative, then we'll say state equals state number. Else, and then we hit the index plus plus. Otherwise, I guess we always do this. It's just the question becomes, and then we also have to have an output equals 0, and we'll return the output. Put these on multiple lines. So if we're in the sign or number state, then we're gonna basically instantly switch this to the state. We should call this state. We're gonna instantly switch to the number state, but if we see a negative character, then the sign becomes negative and we increment. Otherwise, we stay on the same thing because we want to make sure that we're processing the number. So we have state number. Now, we could parse it, but I think parsing is cheating. I think it's better to say const 0 equals dot char code at 0. I believe 0 is the first number in the sequence of numbers in terms of ASCII. Sign this conversion, read the integer by skipping leading zeros. Returning a non-digit character is considered end. Or the end of a string is reached if digits are read. If no digits are read, the result is 0. Skipping leading zeros until non-digit character is counted. Interesting. Okay. So let's say const value equals character dot char code at 0, and then we'll say minus 0. And so if value is, we're gonna do 0 is less than equal to value, and value is less than equal to 9, then we will do output plus equals equals output times 10 plus value. Else increment index. Else we return the output early. Basically we want to see if we're getting a number 0 to 9. If we do, then that's the next digit in the number, so we need to like multiply our current number by 10, basically pushing all the digits over by 1, and then add that value as a new ones place. So we'll run it. Char code. Oh my gosh. Didn't put a dot length there, which meant who knows. Runs forever, I guess. Okay, so we didn't get the negative. So for some reason we're not going into here. So let's put a console log, and we'll do state character sign index. See if we ever enter this. We do, it's sign or number, the character is the minus sign. Is it like a different minus sign? Oh my gosh, it's not. I'm just not multiplying it out. Alright, we'll run it. Okay, so this is the way that an interviewer would expect you to write this algorithm as a finite state machine. You could probably do it with one less state, but I think it'd be very hard, to be honest. Basically, we start out in this white space state where we're just skipping all white spaces. Every time we see a white space, we skip. If we don't see a white space, then we switch to a different state, which is looking, do we see a sign or a number? Basically, there's only one chance to see a sign. Only one chance to see a sign. If we do see the sign, then yeah, we're gonna increment and say that the sign is negative. Otherwise, we don't increment. We stay there because it could be a number that we need to read. And so we switch this number state. The we're basically determining a number based on its char code. So in like ASCII characters, char codes, in terms of ordering, there's like a whole bunch of numbers before the numbers, or there's a whole bunch of characters before the numbers, a whole bunch of characters after the numbers, but the numbers go from 0 to 9. So we're basically taking the char code of 0, which is like, I don't know, 60, let's say. That would be 60. And then we get take the char code of whatever thing we are looking at, which could be like 69, 68, 67, 66. And we basically take 66 minus 60 and we get 6 for the value. 6 is between 0 and 9. So we apply that to our output. If we find something that's not a character, then we opt out early and return the output times sign. We could break. I don't like breaks. I think breaks are cheating. So we'll submit it and see how we did. Something that I didn't mention is that there is another way to potentially write this code, but at any rate, it doesn't even seem like we have a valid output. So I guess there's an edge case that we missed, because they gave this as input, and our output was this, but they expected a totally different number. So we gotta go back to the description and see. Okay, so there is, the integer is out of bounds, and then it needs to be remain in bounds. Okay, so we just missed an edge case constraint here. We can say const bound equals 2 to the power of 31. And I don't want to write the same code twice, so I will be breaking out of this. I know I said it was cheating, but yeah, it's just better to write code one time. Let's see. So what we're going to do is a math.max and a math.min. So we want bound, and bound, I think this is negative bound, and this is -1. So we're just looking at this. That's between -2 to the 31 and 2 to the 31 minus 1. So this is 2 to the 31 minus 1, we're doing the min on that because if the number goes beyond that, we want to take the smaller value. And similarly, this is just -2 to 31. We're using the max because if the number goes below this, we want to use the bigger of the two numbers. So let's submit it. Okay. I did not know that there was a plus variant. So important to read all of the requirements. In this case, we just increment index. So many test cases. Okay, so I know why this isn't the fastest. It's because we hard-coded, we coded it all out. There's nothing wrong with doing a finite state machine. This is the answer that an interviewer would be looking for. I can imagine that a faster solution, if we really wanted it, would be s.trim, even trim start, new number. Actually, we can even do parse int. Null is not value for expected return type integer. That's interesting. Do we even need to, I'm curious if we even need to trim here. Try a new number. I'm just trying to see how flexible the TypeScript 42 is not valid value for the expected return type integer. What? That's curious. I thought that this would have been like fairly straightforward. What does parsing do? So in this case, it should return 0. Okay. Unknown network error, please try reloading. Right? Now, I think this will likely get a better runtime. Obviously it's less code, and most of the code that is running in the, actually there's one more thing to do. I imagine this will run in 0 milliseconds, but wow. Interesting. Okay. I mean, yeah, if we wanted to do it in less lines of code, this is a way to do it, but I'm curious how you do it even faster. Oh, well. I got lucky. My finite state machine eventually ran in 0 milliseconds. Perfect. Okay, so let's look at the best solution. Oh, wow. Oh, okay. Alright, so let's try to gather an understanding. So they just trim. They don't even try to process spaces like we did. And then after they trim, if there's nothing to process, yeah, it's fine. It should automatically be handled by everything else. Depending on how you write the code. But yeah, they don't do a finite state machine. They just kind of keep track of the state by through the just brute force of how the code is written. Essentially, they just this is the new state. After this they process all the the spaces, After this, they process the sign. This part is interesting. They see if the number is in range. If it's not, then they break. Which we did kind of do that too, but we didn't compare the characters against each other. We compared the resulting number. Here they actually put a plus sign in front of what would be a string, which JavaScript has an interesting way of handling. If it sees a plus sign in front of something, it's going to be like, that's a number, and it'll convert it. So if this is like the string 0 through 9, it'll convert it to 0, 1, 2, 3, 4, 5, whatever. This is interesting. They're basically like, what? What's this? Wait, what is this doing? I thought that I knew what they're doing for a second, but I don't. If the result is greater than int max divided by 10, Lord, why? I think that they're just doing this one step earlier. If they just, it's interesting that they have this in the loop to kind of opt out early. I think that's a cool idea, but they could have done it on this line and not done the division by 10. They're basically like predicting that when this line of code runs, it'll be bigger or less than these values, but they could have just did this after this line, avoided the division by 10. Digit greater than 7. What is digit? This is very random. Is it 7, 8, 9? I mean, it's probably essential for their. It's probably because of a division by 10 issue or something. No, it's not division by 10 issue. It's probably because 7, 8, or 9 has the ability to, are the only ones that have the ability to go over in this case. If sign equals 1. Yeah, I mean, they just overcomplicated this part, but that's okay. Okay, so they manually processed their white spaces separately, and then they processed their sign, and that determines where I is. So they did a pseudo finite state machine as well. They had the same logic. What? Why would they do the same logic? They even know about the digit greater than 7. That's crazy. The other problem is they're doing this every iteration. Every single time they do this. So this makes the algorithm slower. It's better to just, it has the potential to opt out early. Sure. But you're running it a few times before the fact. And maybe there's worst case scenario for very large numbers. Maybe there's the chance that it does get very large. And there's just no point of running the algorithm anymore. But it's just like, just do it after the equals result. Like divide 10, digit greater than 7. It's just like, it's really hard to read. I'm curious if anyone doesn't do it with this approach, so I'm gonna click through and see. Wow, everyone actually... Oh, this one looks interesting. Because they have a regex. This regex is like, at the beginning, there's a plus or a minus, maybe. Then there's a bunch of numbers, and then there's a decimal, and then there's more numbers, maybe, which is non-capturing. This is really hard to read. Oh, well, they just wrote it out. Wow. Does anyone do like the naive solution? Zero more spaces, plus or minus, digits. If not a match, turn 0. Wow. Convert the number to a string. Wow. They use a capturing group. Look at the captured group. Parse it to a number. So they use regex, and it's like one of the slower solutions for sure. Okay. I mean, nobody really... I'm surprised. I thought people would have done it this way. Like, this is 2 lines of code. I mean, yeah, 2 lines of code. And no one really did it this way. But this is what an interviewer is looking for, anyway. Cool. Alright, let's look at another problem. Would do another medium. Container with the most water. You're given an integer array height of length n. Okay, so this is height. And it's length n. There are n vertical lines drawn such that 2 endpoints are I sub 0 and I sub I. Find the 2 lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water the container can store. Notice that you may not slant the container. Okay, this actually reminds me of a problem. I've solved this problem kind of before, years ago. Let's see if I remember it though. I'm wondering if there's a naive solution. The naive solution I think would be like n squared. Just check every single thing and find the max. What are we trying to return? The max amount of water a container can store. And so, yeah, it would just be 1, 2, 3, 4, 5, 6, 7, and this is 7 high. The above vertical lines are represented by an array. In this case, the max water contained is 49. Let's write a naive solution and then we'll think while we do that. I is less than height dot length, I plus plus, or let j equals 0, I plus 1. j is less than height dot length, j plus plus. We'll say let max equals 0, return max. And so max equals math.max of max, and then we'll have that term, and the other term is going to be j minus I times math.max of height sub I and height sub j. Let's just see if that works at all. Alright, so we got 49. So my idea essentially here was we're gonna go through each and every single combination, and basically the volume that we can fit is going to be the distance between them times the the shorter of the two. Of course, it's the shorter of the two. There's no way you could add more water than that. But obviously this is an n squared algorithm, which is not great. So I guess let's try to think a little bit more deeply here. What is this? Oh, you could time your... Interesting. Let's just like list out ideas. Is there a recursive way? Is there a way to use a map? Is there a way to use dynamic programming? Important note that we are currently n squared. So potential improvements could be n log n and n. I can imagine us being able to do maybe n log n, but I don't know about n. See, it might be easy enough to like find the two highest bars, but if they're too close together, that's a problem. Because you can have two really small bars that are really far apart that do better than two long ones that are really close together. So it's not that easy to just find the tallest ones. This is a medium problem, and I think there is an optimization, because I remember there being a better solution. I just don't remember exactly the solution. Oh, I'm not allowed to see that. Greedy. Let's submit it. I'm just curious how many people optimize. Okay, well, you do need to optimize, it seems. If you don't optimize, you won't even get past the test case. So if that's the case, most people are going to have optimized. So the question is how to optimize. Notice that you may not slant the container. In this case, area is blue, 49, 11. Do the constraints help us at all? They could be 0. There's always at least 2. Okay, so it's a greedy algorithm, and I'm not really like well versed in how to do greedy algorithms. Is part of the problem, at least. Because if we're here, is there any way to know that this is gonna be better, even if we like logarithmically divided the problem? I don't think that like going to the middle. I wonder if we can make like an assumption about the height of this. I think I'm gonna use a hint, maybe? Maybe this hint helps. Yeah, yeah, it's not efficient. Always move the pointer that points to the lower line. Try to use 2 pointers. Set 1 pointer to the left, 1 to the right. Okay. Alright, I'll try that. So basically we have left equals 0, right equals height dot length minus 1. And I guess we'll say while left is less than or equal to right. Less than right. And then we'll probably also keep max. And then we'll say max equals math.x of max and right minus left times math.min of height sub left plus height sub right. And then I guess if height sub left is less than height sub right, only move the smaller one. Always move the pointer that points to the lower line. So if we do this, we do this. Now, this is actually big O N? What the heck? It's right, minus. Oh, I don't even have the right syntax. Oh, no semicolon there. Okay. That's kind of crazy to me. I guess the idea is you are trying to prioritize being as far apart as possible. And so when you're focusing on that, the next best thing is to try to find something bigger. And so if you're going to decrement your width, the best thing to do is to increment your height. If you can. It's not super intuitive. I would like to see what the third hint is though. Oh, there's a way to run it faster. I might just be getting unlucky though. Who cares about the n squared algorithm? Wow, I made it slower. Dang. Fine. You'd think that caching the value would be faster. Oh, I just keep getting slower and slower, what the heck? That's okay. I think I'm just getting unlucky. Let's look at other solutions. Yeah. I mean, the best solution, we have pretty much the same code. The next best solution, same. Next best, same. Same. The thing is, they got 0 milliseconds. Which is kind of crazy. Oh, J is n minus 1. I thought I saw 2 for some reason. Okay, so what was the third hint? Second hint was more helpful. But with this new code, it is big O-N, which is surprising to me. I think the greedy algorithm is pretty important. I'm curious the applications of it though. This will be something I keep in mind though, if I know that an algorithm is greedy, to use pointers. It's not super intuitive. Okay. Let's do another medium. Integer to Roman, no thank you. No thank you. Given an integer array nums, return all triplets such that I is not j, I is not k, j is not k, summing to 3 is equal to 0. If I was J and I was K and J was K, the only number that works for it would be 0. So I don't even understand per se why the indexing matters. So 2-sum is easier. 3-sum becomes a little bit more complicated. I think I've also done this in an interview. I think I'm gonna learn something new today. So we gotta find 3 numbers that add up to 0. Okay. I could probably write it in... I could think of a solution that does it in n squared, at least. Which would require a map. And we would say for let I equals 0, I is less than nums.length, I plus plus, or let j... Maybe, is there a way to do this more intelligently? Like to do multiple passes of n? Is n squared the best we could do, or is n... Or can we do it in n? There are hints. I don't think that I'll go for them right away. I want to see if I can get an answer first. Let's just see. Intuitively, or at least my intuition tells me, that n squared is better than n cubed. N cubed, to me, is also a likely candidate, but it's obviously not the best candidate. J is less than nums.length, j plus plus. We're gonna say map sub I plus j. No. Num sub I plus num sub j equals I j. Hey Jibang, how's it going? Good morning. So we'll use this n squared here to create a mapping to keep track of like our sums so far, and then we'll do another for loop. I is less than nums.length, I plus plus, and for this one we're going to try to find a pairing, which I think is actually pretty easy. We'll just say map sub num sub I. Basically, we got to find something that counters out the thing that we're looking for. Counters out the thing that we have. Which it would be the negative of what we have. Really like how you're talking through your solution. Yeah, and I think that this is really helpful for during the interview, talking through the actual solution. It's challenging at first, but if you get practice at it, it's just like any other skill. If you get enough practice, you'll get good at it. I don't have anything scheduled at the moment, but I did just have an interview the other day for I think it was a third. So I had a take home. I guess I had the intro with the CTO, then I had a take home, then I had a coding challenge, which was like more real world coding challenge. Then I had a I guess system design interview, and I think I have 2 to 3 more interviews for this one company. I'm really excited about that company. I really hope that works out. But yeah, interview process for tech is it's a bit much sometimes. We're gonna see if there is a pairing. It is a startup. Yes, it is a startup. I don't think it's more than like 2-year-old startup though. And not pairs dot includes I. Then what are we supposed to return here anyway? Return the numbers. What do we return? The numbers. Gosh, I remember actually I remember an interview where I got this question, and it was for a thank you. I don't mind you asking questions, but I remember I got this question or a similar question during a tech interview, and I could only figure out the n cubed solution. I couldn't think of the n squared solution, and I think they were even trying to push the idea that there was an n solution, which maybe there is, and we'll find out later. But I had never felt more stressed or such imposter syndrome during that interview. The interviewer was like not trying to collaborate at all. And I walked out of that interview feeling so depressed. And the funny thing is that the company was a mental health company. And so I almost felt like they were trying to find new subscribers to their service, and they were intentionally creating mentally distressed people through their interview process, people that they knew could pay for the service as well. But yeah, I really prefer interviews where they want to work more collaboratively during the interview than be like, oh, you don't know this? Another streamer that I watch talks about this idea of like a secret handshake, and if you know the secret handshake, that's like you're in. You have an interview today? Nice. Good luck on the interview. What are they looking for in this interview, if you don't mind me asking? We're gonna run this and just make sure we don't crash, make sure we don't infinite loop, see if we can get a valid answer here. -1 is not valid for the expected return type. List of integers. Oh, there's more than one? Oh my gosh, you can have multiple outputs. I did not read that. Lower level software engineer position, 75 minutes. Whew. Behavioral, technical, conversation, live code pad. Wow. Yeah, good luck with that. I really enjoy the coding parts for sure. Okay, so for whatever reason we're not putting enough items. Oh no. Thank you, thank you. I'm just I'm waiting. At this point, I'm just waiting for the next step. I just finished the step, and I'm waiting for them to get back to me. Just hoping that I get some good news that they want to keep meeting. The order moves? I mean, I also have too many, but the order matters. It seems like. It can't contain any duplicate triplets. Oh, these are duplicates. I guess if I gotta like mark it as consumed. To reduce duplicates. Oh, that didn't do anything. Oh, this triplet is, oh my gosh. As these become 0. That's so interesting. The order of the output and the order of the triplets doesn't matter. It seems like it does, because it's like, why is... Okay, so how do we detect that we've seen this? Because this is not... They're not really true duplicates, I guess. What's the input? I almost feel like if they don't want duplicates, that we shouldn't have... I don't know. No, let's not do that. How do we detect that we already have this triplet? Is the question. I'm not gonna add a sort. That seems horrible, like a absolutely horrible idea. So how do we detect that we already have a triplet? Gosh. I need a hint. If we fix X, we're left with the two-sum problem at hand. Right. So we gotta take the two-sum solution and use it for the three-sum solution. Okay. So that the search becomes faster. Yeah, I'm doing that. The search is faster. The only problem is that how do you deduplicate? That's what I can't figure out. How do you deduplicate? Because I feel like the indices are different for all of these. Like if I do console.log I pairs sub 0 pairs sub 1, run that. Oh, it's the same. But like this -1 and this -1 have the potential to make the pairing with this. So I'm curious why. Oh, maybe it used to. I was so confused. Give me a hint about deduping. Can we use additional space somehow, like maybe a hash map, speed up the search? No, I need to know how to dedupe. So 2 and 4, 1 and 4. 2, 0, 1, 2, 3, 4. 4, 1 and 4. Yeah, I guess the other interesting thing is that we have the potential to lose some triplets, because if these numbers add up to the same as another two numbers, we'll lose a triplet, which is not good. The 3 hints unfortunately did not help me. Map num sub I, map num sub j, ij. So now I feel like I have to like push this. I think I have to. And then we gotta do like pair. Pairs dot map dot for each pair If pair dot includes I, if not pair, and this is actually going to be worse, but I just want to see if it runs. This should be pair. There gotta be like some kind of algorithm that like dedupes at the end. But how? How to dedupe? Are any of them correct? Oh, this one's correct. Nice. How do I dedupe without doing something crazy? Or how do I not add duplicates in the first place? Is the alternative question. One thing I could do is just like console log the map just to see what it looks like for some of these. So 0, 2, 2, and 4 make 0. 0 and 2, 2 and 2 and 4. Yeah, that is true. But they could make 0 for different reasons. The thing is, I can't just like look at the sum either, because they could sum to this. Can I? No. Oh my god! Like, you can't look at the sum, of course, because they all sum to 0. Every triplet sums up to 0, so you can't just add them all and be like, oh, is this the same? To me, it's not even... I'm also curious if n squared is the best we could do. Which is value minus x with a value of a character. So let's read these hints. So we essentially need to find 3 numbers x, y, z, say out to a given value. if we fix one of the numbers, say x, we are left with the two-sum problem at hand. The two-sum problem being that we need to find two numbers that add up to another number. But again, how do you dedupe? Like the idea is that we could call the two-sum function with num sub I, num sub j, and then num sub zero, whatever. Yeah, how do you know the index is different? This one's hard. This is only medium. Struggling. Where the value is the input parameter. Can you change our array somehow so that this search becomes faster? Can we change our array somehow? Does sorting help? Without changing array, can we speed up the search? I just need to figure out how to cut off these last few ones. Okay. Maybe this helps? I'm not a big fan of it, but at least the triplets will be all equal. Well, it'll be all ordered. We only had to do sort once. Now they're all ordered. And so we could do something where we say const already seen, and we could say triplet equals this if not already seen. Const key equals triplet dot join key triplet, and then already seen sub key equals true. I guess we could do a set. And say dot has key and dot add Why isn't this sorted? That's maybe I have to sort the triplet then. Oh, it's so bad. I just want it to work. Okay. Basically we need to do like an insert sort. Let's see how horrible we're doing. Run this. Submit it. Does it even run? Is this greedy? There's just sorting involved. 2 pointers. 2 pointers, huh? So I think the 2 sum was big O N. Is there a way to make this big O N too? Just to avoid that, you say const A equals B equals C equals I think like C is greater than B. C is greater than A. A, C, B. -1, 0, 1, -1, 2, -1. Interesting. Oh, because we still need to do nums dot sort A, B, A minus B. Wow, we could do it in N? That's crazy. 2 pointers. Second train of thought to some is without changing the array, we use additional space somehow. We are doing that. We fix one number, scan the entire array, find the next number, which is value minus x. Which is value? What's value? Value, where value is the input parameter. My goodness. Okay, I think we need to sort it. But like, do we need to use like binary search? This is definitely overkill at the moment. Like this sorting is a lot. I feel like we have to sort the nums though. If we find 3 numbers x, y, z, we fix one of the numbers x, we're left with the 2-sum problem at hand. So we have to find 2 numbers that sum up to x, but we need to exclude another number. But again, it's n squared. That's still n squared. An algorithm that I could think of. N squared. Is there a way to do it in n? Which is value minus x. Value is the input parameter. The value is the x plus y. Who would have thought a medium would be this bad? Obviously the runtimes of those are good. I actually don't need an argument here. How is this medium? It's embarrassing. I've had this question before in an interview. Can we use 2 pointers to help us? The one thing that I'm thinking of is like an n squared log n algorithm, but that's not better than n squared. We need to find 3 numbers x, y, z such that they add up to the given value. If we fix one of the numbers x, we're left with the 2-sum problem at hand. Yeah, but even that is... we'd have to do n nested in n, which is n squared, which is as good as I've done so far. The 2-sum problem, if we fix one of the numbers, scan the entire array, to find the next number y. Well, the input which is value minus x, where value is the... what is the input parameter? I might have to come back to this. I don't think I'm ready for it. I am not ready for it. We're gonna do... let's code it hard. Alright, regular expression matching. Let me just do this. Given an input S and a pattern P, implement regular expression matching to support dot and star. Sure. Dot matches a single character, star matches more of the preceding element. It'd be interesting if they gave me more to work with here, but that's fine. I do const... I don't even... how do you stop it from being greedy though? Star 0 or more. Oh, okay. So we can do dot and we could do star, but there's also other things we could do, right? Yeah, a star, a. Okay. And then what do we return? True or false? Okay. I'm thinking that it might be good to use recursion for this because we need to be able to step back sometimes. That is what my intuition tells me. So this needs to take another argument of like state and index is 0 by default for this state. It'll be basically be pointing at the index that we're index of the I guess string index regex index. Well, what's going on here? Okay. So basically, if S, let's look at the token equals P sub state dot regex index and const character S sub state dot string index. So if token equals star, else so if it's star, we need to look back a character. Okay, we don't have to worry about validation. This is good. And then maybe we do previous equals S sub state dot we might have to create a variable here. I don't even know. I've always heard that regex does what it does using a finite state machine, but I'm not really able to think how it retains like where it is in the regex and where it is in the string without like having to manage an internal stack on top of everything else. And if you're going to use a stack, you might as well use a recursion. So just want your state there. This is previous token is p sub regex index. I'm gonna rename these. String. I guess P is short for pattern, but it just wasn't clicking for me. So I think there's got to be a variation. Is it look ahead or look back? Oh my gosh. So regex has to be greedy. I guess we could do next token. I'll say if not match character token, return false, return true, match character token, if return token is the dot character or token is character. And then string index plus plus regex index plus plus. This I think this handles when there is not a star. The hard part is how do we do this part? How do we convince it to be greedy? Pretty much. I'm still thinking recursion, because it's the easiest way to like keep track of state and like get back to a previous state. So like for let I equals equals 0, I is less than I don't know what I is less than. I'm gonna put false for now and do I++. And we would do like if is match return true. And this is going to be like string regex and string index equals string index regex index regex index. I think for all of these, the regex index is going to increase. The string index is going to depend on I. Basically, we're consuming a certain number of characters, but I think we could do string index as a starting point and just make this I, and do straight I is less than string dot length. Basically, if we see the next token is a star, we have to do the same check here. Yeah. If string sub I. So we'll go through the rest of the string. If we eventually hit something that doesn't match the token, then we can't consume the entire string. And then if we do, well, we have the potential to consume nothing. So I think we have to do the second. Something like that. Oh, we got true. Oh, we're not looping. While string index is less than string dot length and regex index is less than the regex dot length. Maybe infinite loops? Because this block never processes. So A star, it should match. So these all seem correct. The next token is indeed star. Let's do some new lines here. So we're at 0, and so string index is match string regex. String index is I, because this is where we take 0 elements, and then we just move on to the next part of the regex. If we get to here, then we need to see if we can match the 1. If we can't, then we return false. So anyway, starting index I is 0. String index equals regex index equals. So I think we probably infinitely we infinitely recurse. So maybe we have to see how greedy we could be, and that would be our limit. And then we have to work our way backwards. I think we want to be as greedy as possible initially. We could be less greedy initially though. Maybe we can do token plus. No, we can't do that. I think we have to do this. See how greedy we could be? And we do match string sub regex string index plus greed. Token greed plus plus, and then we start at greed. Actually, we could just have while greed is greater than 0. We don't need this. We do greed minus minus. It's not a for loop, it's a while. And this is gonna be string index plus greed. Take as much as we can, be as greedy as we can be. And then work our way down. That's the idea. See if it works in practice. Okay. Time limit exceeded. Interesting. So let's go through it. String index is 0, character is A, token is dot, next token is star. While string index is less than string length, regex index less than regex dot length. I I think we had to return false here. Okay. So let's continue. String index less than, I think the string is AB. Let's do some new lines here. AB dot star. Okay. So yeah, 0 is less than 2, 0 is less than 2. Next token is the star character. So greed, while we match with the token, we should increase greed. The token is dot, so it should be greedy. Yep. Just put return false here. We're still exceeding that time limit. Let's do this. Regex index character token next token. Is something going wrong? The token should be A, okay. Okay, so right now case 1 is fine, case 2 and 3 are not. What happens when we run now? It doesn't even say none of the test cases are fine. Have you kept working on the tree problem? I think I finished it yesterday. Let me pull it up. I basically sorted by most children. It's not optimized though, but I sorted by most children and pulled like the root of the two most, and then made their children the new roots of both, and just kept doing that systematically. Pull the ones with the most, pairing those, pulling their children up to the root. I mean, with the test input, it worked, but I don't know if there's some edge case I didn't test. But I also I posted the video. Let me see. for the TS Fiddle. Thanks for coming back, Solaris. So yeah, not optimized, but basically, as long as there's 2 children, we sort them in descending order. Most children, next most children, next most children. And basically just removing B, we remove A, and then we pair those together essentially. All I can say is that this was the expected output, and it does match. So whether it's correct or not is a totally different question. We could try to think of like edge cases to see if we can break this. But like, to me, ultimately, there's no reason not to just group siblings together. And as you group siblings together, just to pull their children up, and there's the new siblings. There would never be a collision of superiority and whatnot in that case. The only question I would have is there a scenario in which there would be no pairings left? Trying to think of a scenario where there's like a really deep tree. Yeah, okay. I could put in I could put in any input you want. Not sure I know how to input that. They have bigger hidden test cases. Oh, okay, I didn't know that. But like another thing that I do is while there is like in theory a time that could occur where there are absolutely no siblings. Let me pop this out. It's over here. You're saying to copy paste this? You want to be sure you can create a Codeforce account, it's pretty quick. Yeah, okay. Let's verify. Okay. And then the link that you shared. That's that link. Let me go to my channel because I know I put the link to the Codeforce there. Oh, I'm not logged in on this browser. Okay, I'm gonna slide that away for a moment. Remember me for a month. Confirm your email. What? Okay. Okay. And then we'll go to this, refresh hopefully. Go back to chat. You would have to change the beginning of your code to parse the input from standard input. Damn. Choose file, submit. JavaScript. It's upload as a file? You can click on submit at the top. Okay. Submit code. Problem F. I feel like a kid or an old man. How do you, is there, I don't know how to read from standard. Yeah, but you're saying that I have to read from standard input first. So I just gotta figure that out. I just want to read it all. I don't want to read line. Which one didn't have read line? Just one I saw something without read line. Guess I have to do a loop. Oh gosh, this is. I think this is what I would prefer. Let me do const read. Return new promise. Resolve. Const data is an empty array. Return or resolve data.join empty string. Oh, did I do TypeScript? No, I did TypeScript. Does this take TypeScript? No, I had to convert it. Then I guess I'll create a function called parse. Parse. Return input. This will be parse. We will declare it as a function. Like so. And then data will be a string. And that's parse. I will make this a function as well. And then we'll do await read. I didn't make it async. No, it's a promise. I'm returning a promise. What's wrong? Type of unknown. It's not assignable parameter type string. That's because I didn't put string here. Is it not like high level, top level awaits? Yeah. Then stdio. stdio. And then I have the console log the correct stuff too. So let's run it. Do return stdio for now. What? Read is not a function. What? Yes, it is. Okay. Looks like the output is correct. So for this, I suppose, keep the functions together. Get it as JS. Can comment out this line. Copy all of this. Go to here. Why are you unhappy? Don't make functions in a loop. What? Really? That's fine. didn't compile. Strict mode. How do you do this? Is it use strict? So weird. Alright, I'll try it in a second. Oh, I can't submit. Oh. F. Using JavaScript on CodeForce. Running and testing code locally, I use D8. Print, write, read line. Oh, I just gotta figure out these compilation errors. D7. Oh. Okay. How do I compile it for an older file, like binary? Alright, just don't use a default value, I guess. Oh gosh, where is it? It's the toString or something for the class. Okay. Once we get it to compile, it'll be fine. Submit F this code. Submit. Awesome. I didn't use that. Oh my gosh. No. Can you do it for me? So I don't have to do it every single time. Thank you. Cool. Submit F. Here. Submit. Wrong answer. What do you mean, wrong answer? Wrong answer. Answer contains longer sequence, like 6, but output contains. Oh my gosh. Okay, so this is probably the printing stuff that this article is talking about. I think it's, at least if I'm understanding it correctly, it doesn't think I'm printing anything. I'll try calling print. I'll believe it when I see it, I suppose. Hmm. It's either that or the reading's not working. Submit. F. Paste. Submit. I mean, yeah, I'm not printing. Okay, how do I read multiple lines? So like magic. Okay. I will read line. Oh, it's so much I have to change. So much I have to change. Read line. The first line is how many tests? The next is read line. Parse int. Parse int. Next, rankings. Read line. Dot split. Dot map. Parse int. Okay. Here, submit. F. Submit. Runtime error. Read line is not defined. Did I really do a capital L? Why did I do that? Yes, I did. I'm gonna do just for the sake of sanity. LeetCode, you can pass data in std in corner and see the output. You're talking about like Oh, in like LeetCode? Print console.log input. But why are you unhappy? Is there something called print already? No? Oh, is it like the global browser print? Dang. Anyway, this is working fine for me. I don't mind copy pasting as long as I don't get banned for over submitting. Did I instantly fail? What the heck? Okay. Well, that's good to know. It just seems like I'm not logging at all. So I'm gonna pull this up again. Maybe I have to use a different JavaScript. How to read inputs using JavaScript V8, yes. Read line print, yes. Flipping through multiple lines, yes. Okay, I'm just gonna add a bunch of more print statements then. All right, this has to print something. F. Runtime. Oh my god, I copy pasted too much. No. Okay. Submit. Output 641 NAN. Can I report for children undefined? No children, push this. Okay. Let me go here and do dot split. And then this will be stdio dot shift. Try to run this. Oh, okay. Well, apparently I broke it. There is an NAN here, which I don't know why that happens. Wish I could understand that. Why number works with parsint does not work. Anyway, Take all this, copy it. Hopefully we removed all the prints. Submit. Choose F here, submit. Okay, we got past test 1 at least. Expected 2, found 3. Alright, test 2 is wrong. Excellent. The 148th number differs. Expected 2, found 3. Is that all? Just one test? So I found one more pairing than they found. There is a ... here, so I imagine it's not showing all of the output or input. Certainly not the 148th. There's no way that's 148. Oh no. Oh, I guess to answer your question, unfortunately they only give you the first cases of the test. And it worked for the first 47 test case, test 2. Yeah. Trying to think why I might get one more than they might have gotten. Does that mean that I'm potentially pairing people that shouldn't be paired? I mean, I know what I could do to kind of cheat the system. Maybe. No, I don't know what I could do. Probably wouldn't. I probably wouldn't keep outputting unless I kept... It wouldn't keep inputting unless I kept outputting, and probably if I don't output the right thing, it might not input. Probably. I doubt that they'll just completely stream everything. If the first few are wrong, probably streams it like a line at a time, waits for output. So they don't like overburden their servers. But, trying to think of what a tree, a bad tree might look like. And I got one more than what they were expecting. So I'm wondering why that might be the case. So I think like the algorithm that I have, take this, bring its children up, bring these 3 children up, and then everything would be match, 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 match. And this would be 1, 2, 3. Black background, purple ink. Can I just change the background here? Oh, it's not how I expected that tool to work, but it's fine with me. Okay. So this is the root. He'll never pair with anyone. And I don't think that's the issue. I don't think I'm trying to pair this guy with anyone, because when I call max pairs tree sub 0, that's the root. I don't really consider that. Where do I wait, why do I sort then? Why don't I sort here? Can you let me scroll up? Thank you. Is it just a matter of when I sorted? Killing it. Yeah, it's not optimized. I know. Oh, really? My Big O is horrible. There's no way I did not spend any time optimizing. So obviously sorting it's horrible. Sort in a loop. This is just the worst. So it would be better to be like const max index equals, and especially because every time I sort, I call get child count, which recursively goes down and gets the counts of the children, which is just, again, horrible. Do I call this anywhere else? No. Okay. So we'll get max index of nodes, which is the tree node array, and then we'll do const max equals 0 and 1, I guess. I'll say nodes node sub 0 is greater than nodes sub1 dot value dot value. So we want to put, I don't know, we want to put the biggest one to the left, the smallest one. No, that's biggest. Node sub0 dot value. Dot value. So put it in just plain English. 0, 0 is greater than 1, then 0 is the greatest value, otherwise 1 is the greatest value. Just make a really poor assumption in the beginning, and we'll just return. I have to store the index. Do I need the index? No, I don't. I just need the item. Yeah, I could pre-compute the count as well. You're right. Let's do this optimization and see if we need to do more. Or let I equals 2, I is less than nodes dot length, I plus. I think we could get rid of this, and then we could do like a B. And this can be it, or max index. I'll just call this get max children. Get max at children. I guess FB. Already did all that work. It could be tree. Ah. And these are. Oh no. Hopefully we don't need a return type anymore. And basically, if node sub I dot value is greater than biggest. Why am I looking at value? Get child count B equals node sub 1 dot get child count. This is a B, A, B, biggest. No, I do need the cache. I do need to store something. Yeah. I guess because of the way that I'm kind of pulling things, the children count never decreases because I'm always pulling from the root. So count with a T. Okay, so we no longer need to cache them. So if this is the case, then something else. If node sub I dot child count is greater than second biggest child count, I think second biggest would become node sub I. Second biggest becomes biggest, and then biggest becomes node sub I. Let. And then when I add a direct report, this dot child count plus plus, and then let's say let parent equals this, while parent dot child count plus plus, parent equals parent dot parent. Why not? Very well. Something like this. This is hello, Louis Fitness. Welcome to the stream. It's actually not LeetCode at the moment, but yes, it's a necessary evil. Can't read property undefined of child count, and that's because of this. All right, fine. We'll do const A equals const B equals A, B, run it. Wow, we broke it. We broke it very badly. So it should be 101333, but we no longer have that. sub 0, node sub 1 if A is less than B. Then we'll pick A, otherwise we'll pick B. I kind of wonder if it needs to be less than or equal to. So simple. Okay. Optimized. No, don't choose. Submit. Is a big O n log n? Oh. No, I can't do this. Fine. That is a good question. I don't know at the moment. I haven't really thought about it. Oh no. Expected 8, found 6. Oh, it doesn't even work, so it doesn't even matter what the big O is. Expected 8, found 4. Or found 6. What am I reading? 4. Found 6. So I don't have enough. 394th. I would say in theory it's n log n. In theory. So one thing that I could consider doing as an improvement, another improvement, if we need another improvement, let's get the code working first, but another improvement would be making the list of children a linked list so that they're easily, I have this remove function that basically takes all the children and adds it to the array of the parent, which could be expensive. So I could make them a linked list to avoid that. I guess I could make it -1. So that it'll never get picked by accident. Should child count itself? Probably not. Let's add some more prints. Let's add some prints back just to make sure. Alright, when we run here, we do get the right values, but I would like to see the tree as we progress and the values of A and B. Run it! Oh no, I can't do this. I'll do a dot value. B dot value. And I'll do node dot toString. Question mark, I suppose. And then for the toString, I'm going to add this dot child count. Okay, and then I guess I'll new line that. Where is it? Here. Yes, this says it has 6 children. 1, 2, 3, 4, 5, 6. Yes, this says it has 3 children. That's not right. 2, 3, 4, 5, 6. Why does this have 3 children? Let's see. When we add a direct report, we start with this. This shouldn't be 2, this shouldn't be 1. So the node is the report, right? No. Add direct reporter. Nope, that's the parent. Okay, so we're gonna call this parent. We're gonna call this parent. We're gonna get rid of this parent. We're gonna call this parent, and then we're gonna go to add direct report, type, and say that this can tree node or null. Are we allowed? Gosh, I don't care. Okay, that's better. So let's log less. Go scroll up, run it. 10133. Go to JS. From the use strict downwards. Copy it. Go to here. Exit that. Submit code. F. Copy paste. Submit. No! Is it the same one? What did we get wrong here? 394th. It's the same one. Or we broke it locally and now it's... And then we fix it, now it's broken again. So once again, we go back to debugging. This is 2, this is 1, 0, 0, 0, 0. That's all good. So the first log, we're taking 1 and 3, which is good. Yeah, that's what we want. Then we're taking 2 and 4, which is great. And then we're taking 5 and 6, which is great. One and 3, excellent. This will be 0. Alright, what am I talking about? This is 1, this is 0. This is 1. And then this is 3. And it should be 1, 3. Yep. 2, 4. Yep. 5, 6. Yep. 6, 5, whatever. 2, 1. 3, 5. Yep. 4, 6. Cool. And then this one is 3, 1. Yep. 2, 4. Yep. 6, 5. Yep. Well, it is doing what I expect. What's the difference? Is it still expected 8 got 6? $394th. Okay, just for lulz, we're gonna go back to return nodes dot sort a oh wait, no, b dot value dot child count minus a dot child count, because this worked at some point. And we'll console run it. Okay. JS use strict. No, I didn't copy it all. Here. Submit. F. Here, submit. Okay, so we definitely broke it. What else did we change? All right, I'm gonna copy this over here. Oh, you know what? I don't know what I'm doing. I had a crazy idea, but I could just look at the code that I submitted for test 10. When a node is deleted from the tree, how do you update the subtree sizes? So let me just add this log back. I'll show you. Give me a second just to undo a few things. So I'll run it. So the second value is the number of children. So this has 3 children in total. This is 1 child in total. This has no children. So the way that my algorithm works is it kind of like when I process something, I remove it and then bring its children up. So I would remove this and bring its children up. And I'm always working from this level. I'm not like recursively going deeper. So the children shouldn't be changing. The count of children shouldn't be changing. We can see, like, for example, this one is 3 and then it has 3 still. And then, yeah, I mean, the parent is not correct. This one isn't correct, but it doesn't matter. But then some subtree sizes change. Do they? Well, like looking at this one, for example, there's 3, 2, 0, 0, 0, 0. This guy still has 2, 0, 0, 0. Then these are 0, 0. I think the children counts seem fine. This one's another 2, 0, 0, 2, 1, 0. Then this becomes 0, 0, 1, 0, 0, 0. There's another one, 2, 1, 0, 0, 0, 0, 1, 0, 0, 0. They all look correct. Because the only thing whose children is changing is this one's, but I don't look at that one's. Namely, if you is deleted, then some child of you must move up. So the subtree size of V. If U is deleted, then some child of you, call it V, must move up. Yeah? So the subtree size of V changes. Why? I can draw it, yeah, I can draw it. Where is it? So, like for example, if we process this and process this, then the algorithm that I have will say, well, now this will point to this, and this will point to this, this will point to this, this will point. Let me do different colors. That'll point, this will point here, this will point here, this will point here. And in this case, these are the V's, and all their children would be 0. Yeah. Yeah, that's how it works. Yeah. So that's what this line here does. this line here. As I am removing this, if it has a parent, which it should, I only do this because it's TypeScript. I'm gonna find the index of the child I'm removing, and then I'm gonna splice into the parent's children, the children of the child I just removed. And then the children mark this as their new parent. What did I change so the solution not work? That's a great question. I copied the wrong thing. All right. So I replaced this. I don't want to. What? So adding how we calculate count, I guess, is how we calculate count and how we pick the max, the two max. That's pretty much it. So like I have this very complicated algorithm to get the biggest two nodes. Why does it do that? I don't like that. So in here, children, we get the max children. A is sub 0, B is sub 1. If we did get a second child, then we'll remove B and increase pairs and then remove A. Also how we get child count, so we use this variable rather than this function. And parent child push. So for adding direct reports, I rename this from node to parent, 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 while parent, we increment parent. So basically iterating upwards to alert that the parent count or the child count has increased. What is this? This is just to show the new value. But that's it. So either this is wrong, or this is wrong. Because in actuality, like this code here, nothing really changed. Is the child count counted correctly? I mean, all I can really report on is the logs here. And the numbers look correct to me. Yeah, the number to the right, number to the left is the parent, number to the right is the child and the child count. So for example, this one does have 3 children, this one does have 1 child, this one has 0, this one has 0. It counts everything in the subtree. Then the fourth test case is weird. It must be weird. It must be weird for basically the same two algorithms to not work. Shouldn't that be 4? Wait, what should what be 4? Look at your fourth test case. Can I do that? In my logs, okay. So my fourth one should begin log 4. Okay, I'm looking. Okay. Yeah, this should be 4. Okay. Okay. I think you're onto something. Yeah, you're totally onto something. Good call. Good eye. So I think that the issue is that the order of operations. 4 doesn't have a parent when I add 1, 2, and 3. So I add 1, it gets a child. I add 2, it gets a child. I add 3, it gets a child. But then I add 4 to the root, and I never told the root, hey, by the way, I have 3 children. So I need to say, when I add a node to the parent, I don't just plus plus. I need to do +1 or this dot parent child count plus equals this dot child count plus 1. Okay. Well, I don't want to put the log back. I'm pretty sure that was the issue. Good stuff. That was a good eye. I know, like, as far as we're like frustrating to watch and be like, oh, the answer's right there. But that was a really good catch. If this isn't it, I'll put the logs back in and double check. Oh no. So slow. Suddenly so slow. DDoS? Okay, well, I'll come back to it. Well, while we're waiting, I guess I could put the logs back in. Yep. Okay, so 6. Oh, why aren't you scrolling? Oh, because I'm already scrolled down. 3. 1. This one has 4. It says... It's okay that it doesn't decrement, we don't even care about that one. long term. 6, 6, 6, 6, 6, 6, 6, 6, 6. Okay. No! I don't want to optimize more. Okay. Progress. We've made progress. Thank you. Thank you. Thank you. So we doubled it. We doubled our progress. Let's just look at it at a high level and see if anything else jumps out at us. Actually, I need to take a quick break. Probably like a 30-minute break to take my dog out to go for a little walk and eat some food. So I'll probably be back in like 30 to 60 minutes. But yeah, thanks for hanging out for the moment. I'll be right back. Bye for now.